welcome to our class. We're glad that you made it to the second quarter. In this video, we are going to discuss about earthquakes and faults. So let's get started. In this lesson, you will be using models or illustrations to explain how movements along faults generate earthquake. In this video, we will also learn the relationship between faults and earthquakes, types of faults, and the types of stresses in the Earth's crust. Please listen carefully as I read the article about the earthquake that happens in Luzon. An earthquake with a magnitude of 5.3 jolted Luzon of the Philippines on Sunday morning, the U.S. Geological Survey said. The epicenter, with a depth of 86.86 km, was initially determined to be at 14.04 degrees north latitude and 120.525 degrees east longitude. The three widely felt earthquakes shook the Philippines today, but it's unclear if they triggered each other. The earthquake, which struck at 3:18 in the morning local time on Sunday, was centered in the sea about 31 km or 20 miles northeast of Lubang Island, or 89 km 55 miles west of Calamba, and 65 km or 41 miles southwest of Balanga. The Philippine Institute of Volcanology and Seismology, or PHIVOLCS, said that the quake measured 5.5 and struck at a depth of 85 km or 53 miles, which is relatively deep. There is no threat of a tsunami, but aftershocks are likely, according to PHIVOLCS. Shaking from the earthquake was felt across the region, including in Manila and Quezon City, where some said the tremors were strong enough to wake them. There were no immediate reports of damage or casualties. The Philippines is on the so-called Pacific Ring of Fire, an arc of fault lines circling the Pacific Basin, which are prone to frequent and large earthquakes. Volcanic eruptions also occur frequently in the region. Have you experienced a sudden shaking of the ground? How will you describe the shaking made? Is it light or strong? This trembling or shaking of the Earth's surface is what we call earthquake. It plays an important role in shaping the surface of the Earth. An earthquake is caused by a sudden slip on a fault. The tectonic plates are always slowly moving, but they get stuck at their edges due to friction. When the stress on the edge overcomes the friction, there is an earthquake that releases in the form of energy in waves that travel through the Earth's interior and crust that cause the shaking that we feel. And now, what is a fault? A fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep. Faults may range in length from a few millimeters to thousands of kilometers, and most faults produce repeated displacements over geologic time. How do faults produce quakes? Energy from the Earth's interior makes the ground move. Friction holds the rocks together. Once the friction is overcome, the ground will move and the earthquake will occur. Earthquakes are caused when faults slip suddenly. Friction between the two sides of a fault keeps it from moving until the stress on the fault overcomes the friction. Then the fault slips and creates an earthquake. Faults are classified according to movement of two blocks. There are three types of faults. First, we have normal fault. Second is the reverse fault. And the strike-slip fault. The strike-slip fault is the strike-slip fault. The strike-slip fault is the strike-slip fault. And 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 the strike-slip fault is the strike-slip First, let us know what is a normal fault. A normal fault is a deep slip fault in which the block above the fault has moved downward relative to the blocks below. This type of faulting occurs in response to extension. It occurs when the hanging wall moves downward relative to the footwall. Next one is the reverse fault. Reverse fault, from the word itself reverse, it is a deep slip fault in which the upper block above the fault plane moves up and over the lower block. This type of faulting is common in areas of compression. When the dip angle is shallow, a reverse fault is often described as a thrust fault. It occurs where the hanging wall moves up or is thrust over the footwall. And the last one is the strike-slip fault. It is a fault in which the two blocks slide past one another. There are two types of strike-slip fault movement. First is the left lateral strike-slip fault. If you were to stand on the fault and look along its length, this is a type of strike-slip fault where the left block moves toward you and the right block moves away. Second is the right lateral strike-slip fault. And if you were now to stand on the fault and look along its length, this is a type of strike-slip fault where the right block moves toward you and left block moves away. The San Andreas fault is an example of a right lateral fault. The Earth has three layers: the crust, the mantle, and the core. By familiarizing the Earth's layers, you will have an idea that all of them have something to do in earthquake formation. The Earth's crust is like the shell of an egg. It is the thinnest of the Earth's layers. The crust is broken into several parts known as the continental plates. The extreme heat that comes from the ground that wants to escape from the Earth's surface makes the plates move and causes trembling. When the plates are pulled or pushed together, stress occurs. The lithosphere part of the Earth is made up of these giant basalt pieces called tectonic plates. They are constantly moving on a viscous or slowly flowing layer below, called the mantle. It has magma, also known as the hot molten rock, that causes the tectonic plates to move in different ways. These non-stop movements cause stress on the Earth's crust that leads to crack or break formations on the ground called faults. When tectonic plates move, motions at the faults also occur, thus causing wave production known as seismic waves that create earthquakes. There are two types of seismic waves produced: the body waves and the surface waves. Body waves are vibrations that travel in Earth's interior. It has two types, the P waves and S waves. Surface waves are vibrations that travel in Earth's or in core's surface. It has also two types, the Rayleigh waves and love waves. So as we go along with our topic, we are going to discuss the body waves and the surface waves and its different types. And now, what are the types of stresses in the Earth's crust? There are four types of stresses affect the Earth's crust. First is the compression, next tension, third is the shear, and the fourth is the confining stress. First, we have to know what is a compression stress. A compression stress is a type of stress that causes the rocks to push or squeeze against one another. Compression stress is a body waves. Body waves has two types, just like what I have said earlier, the P waves and the S waves. Compression stress is a primary wave or P waves, since it pushes rocks in the direction they are traveling and can travel in all types of matter. It targets the center of the rock and can cause either horizontal or vertical orientation. In horizontal compression stress, the crust can thicken or shorten. In vertical compression stress, the crust can thin out or break off. The force of compression can push rocks together or cause the edges of each plate colliding to rise. Mountains are a result of high-impact compression stress caused when two plates collided. Next one is the shear stress. Shear stress occurs when the force of the stress pushes some of the crust in different directions. When this happens, a large part of the crust can break off, which makes the plate size smaller. Shear stress usually happens when two plates rub against each other as they move in opposite directions. The friction of a shear stress at the edges of the plate can cause earthquakes. Shear stress is also a body waves, or the so-called S-waves or secondary waves. It displaces rocks at right angle to the direction they are traveling and cannot pass through fluids. When body waves reach the Earth's surface, surface waves are formed. Again, when body waves reach the Earth's surface waves are formed. And there are two types of surface waves, the Rayleigh waves and the love waves. Rayleigh waves shake the ground up and down, while the love waves shake the ground from side to side. Let's move on to tension stress. Tension is the opposite of compression. While compression forces the rocks and crust to collide and move together, tension forces the rocks to pull apart. Tension can happen in two ways. Two separate plates can move farther away from each other, or the ends of one plate can move in different directions. Some scientists think tension stress caused the ancient, massive continent Pangaea to break off into the 7 continents we have today. The last one is the confining stress. When stress is applied to all sides of the crust, confining stress occurs. When this happens, the crust compacts, which makes it look smaller. If the stress is too much for the crust to handle, the crust can fracture from the inside. This causes the crust weight to decrease, but the crust shape remains the same. Because this type of stress can hollow out the insides of the crust. Confining stress can cause sinkholes in the earth. Aside from motion of the tectonic plates, underwater or surface land volcanic eruption can cause frequent shakings and aftershocks. Falling of asteroid or meteoroid and even strong explosions can contribute on the trembling of the ground known as earthquake. In addition, earthquake's magnitude is measured using Richter scale, and its intensity is measured using PHIVOX, Earthquake Intensity Scale or PEIS. PHIVOX is the government agency that deals with the study of volcanic activities and earthquakes. And that's the end of our lesson for today. Thank you for listening. Till next time, bye-bye!